Hello students, today we will see the last model is deployment model. Here the component you develop or use as a part of the software system, it must be deployed on the same set of hardware in the order to execute. In deployment diagrams, nodes are used to model the topology of the hardware on which the system executes. A node typically represents a processor or a device on which component may be deployed, and this can be represented by using the deployment diagram. Here you can use a deployment diagram to model the static development view of the system, and this involves modeling the topology of the hardware on which your system execute. And deployment diagrams are essentially class diagram that focus on the system nodes. Here the deployment diagram are used to visualize the topology of the physical component of system, and these components are deployed. Then the term deployment itself describe the purpose of the diagram, and these diagrams are used to describe the hardware components where software components are deployed. Then component diagram and deployment diagrams are closely related, but the component diagrams are used to describe the components and deployment diagram shows they deployed in the hardware. Here the UML is mainly designed to focus on the software artifacts of the system. However, there are two diagrams are special diagrams which is used to focus on the software and hardware components. Then most of the UML diagrams are used to handle logical component, but deployment diagrams are made up to focus on the hardware topology of the system. Then these deployment diagrams are used by the system engineers, and the some here purpose of the deployment diagrams can be described as, then first is it visualize the hardware topology of the system. Then it also describe the hardware component used to deploy the software component, and last one the describe the runtime processing nodes. Here some of notations in deployment diagrams. Then first is here node. This is the symbol for node. A node is a physical resource that execute code component. That means a node is a computational resources upon which artifacts may be deployed for executions. Then second is a device node. This is the symbol for device node. Then a device node is a physical computational resources with processing capability upon which artifacts may be deployed for the executions. And these devices may be complex, that means they may consist of the other devices also. Then third one is the executions environment node. This is the symbol for execution environment node. An execution environment node is a node that offers an execution environment for a specific type of component that are deployed on it, and it is also in executable artifacts. Then association, this is the association symbol, straight line. It refers to a physical connection, that means link between two nodes, and it specifies the semantic relationship that can occur between the type instances. Then component, here this is the component diagram for component. A component which defines its behavior in terms of provided and require some interfaces. Then dependency, this dotted line with arrow is this is the symbol for dependency, and it is the relationship that signifies that a single or a set of model elements which requires other model elements for their specification and implementations. Then here is deployment. This is the symbol for deployment. Deployment is the allocation of an artifact or artifact instance to a deployment target. Then port. This is the symbol for port. A port may specify a service as a classifier provides, that means offers to its environment, as well as services that a classifier aspect which requires some environments. Then here one of the example for deployment diagram. Here the example for order management system. Here the processor, that means catching server, which connect to the server first, server second and server third. Then one of the users, and here one of the modem, that means here the connections which is over the internet. So here one of the deployment process from the processor, and this is the processor. In this video, we have attached some UML diagrams examples. Here we will see some examples like case studies on the structure, behavior and architectures model together. Then we will see the example one by one. Here first one is the use case diagram for automated trading house system. Here use case diagram, that means here use case means it having two nodes, that means actor and use cases are important. Here some actors like customer, individual customer, corporate customer, manager, sales department, these are the actors, and it contains some use cases, that means activities occur. Here the automatic trading house systems. Here this is the boundary of the system, that square box is the system boundary. Then it having some heading automatic trading house system. Then it follows the some use cases. First we accept the orders, then process order and generate the bill, then manage customer account and handle some queries. These are the use cases. But sales departments can handle some use cases like accept order and process order and generate bills. So here connected arrows for only two use cases. Then manager can handle manage the customer account and queries. So here these two use cases join to the manager actor. Then customer can accept the order, customer can also process the order, and customer can handle the queries. So these three use cases connected to the customer actor, but customer cannot manage the customer account, so here it is not connected by the customer actor. Here the customers having some individual customer and corporate customer, so we can generalize these customers this type, these fashions. This is the generalization symbol. So this is the diagram for use case diagram automated trading house system. Then second example is use case diagram for online shopping like credit card processing. Here the merchant credit bank processing system. Here example, this is the module. Then one of the also actor is merchant bank, then customer credit card. It having this is the subsystem and name of the system credit card payment gateway. Then it also performs some use cases like authorize and capture, then authorize, then capture, then credit, void and verify. These diagrams, here the authorize and captures, here the it processes include, and authorize and captures it also include the to the captures. Here includes means this diagram is a directed relationship between the two use cases, so we can use here include symbol, and it also implies that behavior of the included use cases it inserted to the behavior of including some use cases, so we use the included symbol. Then here the merchant banks involves these three use cases like capture, credit and void, so it is connected to these use cases. Then customer credit card bank, it involves some use cases, so this is connected to the customer credit bank. And then merchant credit card processing systems, it involves all the use cases, so it is connected to the all use cases. Then here is another example is deployment diagram for the online shopping. Deployment diagrams only hardware and software purpose, so it shows only hardware and software. Here one of the Oracle database, and one of the Apache Tomcat server. That means it is application server, and which is connected by the LAN. It having some private network like network to the client, so it is shown by the private network as like this. In the deployment diagram, you can show only the hardware and software connectivity. This is called as the deployment diagram. Then another example of deployment here the deployment diagram. Then another example is the class diagram for banking system. Here bank, one of the table is bank. In class diagram we can connect the tables. So first is the bank class or a bank table. It contains here the bank is one of the class, and class contains three contents. One is the name of the class, second attributes of the class, and third one is the operation on the class. Here these three sections. Then first bank is the class name, then name and code. These are the attributes which is involved in the bank class, and then it having some operation like add branch, remove branch, get branch, and get all the branches. Then second class is branch. It having branch code and city, and it having these operations. Then the third class is account, and it having two attributes, account number and balance, and it can having these three operations. Then saving account, current account, customer, and loan. These are the different tables which is connected by the their relationship. Here the bank and branch, it having one to many relationship, one, and this star represent the many. Then second is here we can also here self one to many. Then it having account to the branch, it having many to one relationship. Then it generalize here saving account, current account, because of there are the types of account, saving account and current account, so we can use the generalized symbol. Then it having the customers, here the customers having customer ID, name and address, phone numbers, and it having one to one relationship between one customer having one account, like one customer having one saving account or one customer having one current account, so here connected one to one relationship. Then customer and loan, it having one customer having a zero loan or one customer having many loans. So here the some maybe situation, so it may zero to many, that means zero to star, that means zero to many. Here this is the relationship. In class diagram you can define the class or define the tables in three contents like the class name, class attributes and their operations, and connected their relationship with like one to one, one to many, many to one, as like this. These are the class diagram for banking system. And here another example is sequence diagram for ATM machine. Here this is the customer, one of the actor, then card reader, then ATM session, customer console, and transaction. These are the here customer is actor, and second one is the these are the here name of the classes like here card reader, ATM session, and customer console. Then first step is insert the card. Customer can insert the card to the card reader, then card verification, and here the card inserted. Then it create then message to the ATM, create, then verify the pin, then console customer. Then when pin is verified, then get to the message. Then when message is verified, then create the transaction and perform the transactions, and also continue the transaction to the customer. Then eject the card from ATM machine, so it is connected to the ATM. Then card eject, messages received to the customer. This in sequence diagram you can flow of the system, right? Here this is the sequence diagram, And it also one of the this diagram is not defined. It is also, this is dotted line. Actually this is a dotted line and it represent cross line. That means this cross lines means the lifelines, end of lifelines. These dotted lines represent the lifeline. And it also cross at the last time cross, that means lifeline, end of the lifeline, or destroy the message. When we can stop these messages, then destroy message is the kind of message that represent the request is destroyed. That means life cycle of the target lifetime. Here one of the activity diagram for ATM machine. Here the customer, ATM machine and bank. First step is first activity is insert card. Then first customer, then insert the card, then enter the machine. Then message to the authorize from bank. Then bank having two decision, so we use the decision box like valid pin and invalid pin. If the pin is valid, then enter the amount option is, we have see the enter amount option. If your pin number is invalid, then go to the here eject card. Then here enter amount, then check the amount balance. Here balance is greater or equal to amount, or balance is less or equal to amount. Here also decision occur when balance is greater or equal to amount, then we can take money from the slot. And when amount is less than amount, then we can only show the balance. And if take money from the slot, then we debit your account. And it having also connect to the this take money from the slot and shows the balance. That means here we use the join and fork and it shows the balance, and then eject the card and take the card. These are the activity diagram for ATM machine.